Alright guys, so this is solving rational inequalities, and really this one it's very similar to the solving polynomial inequalities. Follows pretty much the same steps, but where you see that there's a bigger difference in the graph. So now I'm dealing with these vertical asymptotes, and all the rules that we've already talked about, especially when describing rational functions, they apply. So really the only thing that changes here, step one was to find zero, draw the number line, pick test point. You're going to do the same thing. But now that I have the introduction of an asymptote, guys, I am also looking for asymptotes. Okay, so that's really the only thing that changes. I'm also looking for asymptotes. So looking over here, guys, this right here is the graph for a rational inequality. This is the actual equation over here. And again, same rules apply. Here I'm looking for where am I less than 0. So here I'm looking for where am I below the x-axis. So if I look over here, guys, just so we have the answer before we start, this will go from negative infinity all the way to negative 1. Now, because I see the equal sign, this is going to be a bracket. And from right here, I also see that it is below the x-axis, starting at 2, and it goes all the way to, remember, these are x values, and this asymptote's at x equals 3, so it goes all the way to 3. Now, I'm going to put a parentheses here because I'm dealing with an asymptote. Okay, and guys, this x value, I'm never going to reach it. Okay, and so we'll see it a little bit over here, but that's what it is. Okay, so I will never ever reach a asymptote, so that's why I'm always going to use a parenthesis. So a couple more things over here. When I'm dealing with zeros, if I see the greater than equal to less than equal to, the greater than equal to sign, that's when I use brackets. You will not use brackets for the asymptotes. They cannot happen. You'll never reach the point. It's not included. So when I see these signs, the less than or the greater than without the equal sign on the bottom, well, then those will be parentheses. And anytime I'm dealing with an asymptote, I will also be using parentheses for that number. Okay? So what we're going to do over here, guys, is first thing is to find, again, zeros and the asymptotes. So pretty much you're going to do the same thing. You're going to set everything equal to 0. So these on top are the zeros, x minus 2 and x plus 3. So x minus 2. So I have one at x equals 2. X plus 1 equals 0. So at x equals negative 1. And I mean, I can see them over here. This is where I cross the x-axis. And so this is a 0. This is a 0. The only thing is now I have the asymptote, which is with the denominator. So x minus 3 equals 0. X is equal to 3. This is an asymptote. Okay? So remember, you'll never reach this point. So I'm going to go ahead and draw the number line. Okay. So I'm going to go ahead and put these points. So I'm going to start with negative 1. Remember, that's the first one. Positive 2 and positive 3. Okay, so I'm going to go ahead, because I see this equal to sign, I'm going to go ahead and just make this a closed dot. That way I can go ahead and just remember that. And negative 1, that's also a 0, so I'm going to put a closed dot. And asymptote, guys, remember, you will never reach this point. So for this one, I'm going to go ahead and put an open dot. Okay? So step 3 is to pick test points. So again, now I want to choose a number that is smaller than negative 1. Negative 2 works, so I'm just going to go ahead and plug in negative 2, minus 2, negative 2 plus 1, negative 2, minus 3, and I'm going to see if it's less than or equal to 0. Okay, so here, negative number minus a negative number is still negative. Negative number plus a positive number here, well, the negative 2 is bigger, so this would make this still negative. And on the bottom, negative and negative is a negative number. So here, negative times negative is positive. And I still have negative on the bottom. And the positive number divided by a negative number will eventually lead to a negative number. Is that smaller than 0? Yes, it is. So over here, I still have I have a check. Okay? So now I'm going to choose a number between negative 1 and 2. So I'm going to choose at x equals 0. So I should have put that over here. At x equals negative 2. So I'm going to put this again, guys. So 0 minus 2, 0 plus 1, 0 minus 3. And I'm going to check, is this less than 0? So this results in a negative number, up here a positive number, and down here a negative number. So negative times positive is negative over a negative number. Negative divided by negative is positive. So is a positive number smaller than 0? No, so this is not included. Okay? So I'm going to choose a point now in between, so 2.5. Okay, that's between 2 and 3. So 2.5 minus 2, 2.5 plus 1, 2.5 minus 3. So here, 2.5 minus 2 will result in a positive number. 2.5 plus 1 will result in a positive number. And 2.5 minus 3 will result in a negative number. Positive times positive is positive. Divided by a negative will result in a full number that's a negative. Is a negative number smaller than 0? Yeah, so in here, in this little space, that works. And I have one more space, so somewhere over here. So I'm going to choose that x equals 4. So again, just plugging in numbers. So 4 minus 2 will result in a positive number. 4 plus 1 will result in a positive number. And 4 minus 3 will result in a positive number. So all of this, guys, ends up being a positive number. Is a positive number smaller than 0? No, so this is not included in the set. Okay, so just to finish this off here, this is included in my set. So any number that is smaller than negative 1, so to negative infinity all the way to negative 1. And since this one is included in the set because we had filled it in. From here 2 to 3, it is included in the set, but 3 is not. So this would be a bracket, the same thing that I found over here. Okay, so same principles as the polynomial inequalities, is just a little bit more tedious. So this is how you work through these problems, and you'll need this for the test. So go ahead and study, you guys.